All right, spectroscopy and the EM spectrum. So spectroscopy is the idea of using light in order to analyze different types of things. We've seen mass spectroscopy, photoemission spectroscopy. However, this is one area that we look at we're going to look at the visible light in order to determine how actual things are going on. So the electromagnetic spectrum, very simply put down, that the lower the frequency, the lower the energy, and a very large wavelength. As you come across, you have your radio, micro, infrared, visible lights, the very narrow range, ultraviolet, X-ray, and gamma ray. Wavelength decreases, frequency increases. I always think of tying energy to frequency. Higher the frequency, the more energy is present. When we look at the colored world, lowest energy is red, highest energy is violet, which is why ultraviolet rays have more energy than infrared. So I try to go with the colors there. And that the wavelength decreases as you have more energy, just like we saw across all the different types of light. This is how we learn about chem. We often will use light in order to see what we can't see. This can be used in things of structure, handedness, and many other types of properties. So it's very useful, even though it seems more of a physics area. So different energy gets you different results. So based upon how things move when energy is on them is going to help us understand what they are. So this is how we get many of the different complex structures, by exposing it to different types of radiation. Microwave is the lowest that we use, and it tells us about rotational levels. So the energy between things rotating on this plane, and even spinning around all on their own. This, by the way this is done, this helps us determine more about their shapes. Infrared, or IR, higher than microwave, associated with vibrational. So that has the idea that when you have something like water, of how these molecules will move up and down, and kind of asymmetrical is kind of all the different directions. So in and out, getting closer, left or right, or kind of vibrating back and forth. So think of infrared is with vibrational, microwave is with rotational. These are the types of questions that will come up. And that's something you'll go much deeper into when you do college chemistry. NMR is nuclear magnetic resonance. That does another type. But I've done IR spectroscopy when you look at the ideas of what these different types of compounds are. And then the last one is UV vis, which is ultraviolet and visible, highest energy, and it's set for electron energy levels. So you may have seen this. It's called flame tests. When you start to throw different compounds and ignite them with fire, they give off certain wavelengths of light. Now, the different wavelengths of light is essentially how much energy where that excited electrons go when they fall back down. When they fall back down to certain wavelengths, they release energy. The bigger the fall, the more energy. This is a very simple idea when we think of potential energy from physics, that a higher placed rock is going to fall and collide with the ground with more energy than a lower placed rock when it falls and collides. The idea is that these are taken from the ground state to excited states, and the electrons in the ground state can absorb energy to get to these transition excited states. This is very common when we think of with our most simple element, hydrogen. It has different energy levels that it can get to, and so when it cascades back down, it releases those energies of light, giving us our emission spectrum lines in these different colors. And these can be very large, very faint, but this is how we've determined a lot of chemistry based upon the energy being given off. So again, as a little summary, you've got your electron energy levels for UV vis, and you've got your microwave for rotational, infrared for vibrational. All right, come on with any kind of questions that you might have, and catch you later.